Today, I'm going to talk about part two on the ANOVA task, and we're going to do what are called follow-up tests. Follow-up tests, and these are tests that you do after you've done the basic ANOVA, and they kind of help to get into more of the details of the differences between the groups. So we're going to be looking at the same data that we looked at before. This is the puppy data. From the ANOVA Part 1. But what we're going to do is we're going to look at some follow-up procedures we can use to understand more about what's going on with these particular groups. So why do we use follow-up tests? When the basic ANOVA or the F statistic can only tell us if our groups are different from each other. So it can say that these three groups are not equal. It can't say which groups are higher or lower and how much difference there is between individual groups. And so what we use often to help us with that is we use what are called follow-up tests. And those follow-up tests allow more information about where the differences that the ANOVA or the F statistic have picked up on, where those differences actually are at. So the F-test does not tell us specifically which group means differ from which. And so the follow-up tests actually allow us to find out where those group mean differences actually are. The first type of follow-up test we can use is called a planned contrast. And what this does is the variability that's explained by the model, so the sum of squares model, is due to the participants being assigned to different groups. And then this variability can be broken down further to test specific hypotheses about which groups might differ. So we break down the variance according to hypotheses that we make a priori, meaning that these are planned contrasts are always based on hypotheses that you make prior to running the data or your expectations about where some of those group differences might lie. So there's a few rules when we're doing contrasts. One is that the contrasts must not interfere with each other, so they must each test a unique hypothesis. Basically, we tend to do it to where there's only two chunks of a variation, so we want to tend to just look at it in terms of two groups. And then you should always end up with one less contrast than the number of groups that you have. So for in this case, we have three groups, so we only want to have two different contrasts that we're actually going to look at. The way in which we kind of choose these contrasts is to do one of two things. First, we kind of separate out the control groups, and then we compare the single control group to both of the experimental groups. Secondly, we simply compare the different levels of the variable itself. So we compare how much a smaller or lesser amount of the variable compares to a larger. And so that's the way we're going to do it here as well. So the two hypotheses that we're going to look at is, one, people who receive puppy therapy will be happier than those who don't. So in this case, we're going to compare the control group to a combination of the 15-minute plus the 30-minute group. So here again, the planned contrast basically takes the three groups that we have and creates two groups. So one group is our control group, and then the second group is the persons who participated in the puppy therapy for 15 minutes, in addition to the people who participated in the puppy therapy for 30 minutes. So that we create a combined group out of that. Then hypothesis 2 will be people who receive a long dose of puppy therapy will be happier than those who receive a short dose. So in this case, we're going to exclude the control group, meaning we're not going to look at the control group, and we're simply going to compare different levels of puppy therapy or different amounts of time that persons spend doing puppy therapy to see if more puppy therapy increases your happiness in contrast to less puppy therapy. So here's the way the two contrasts work. So the contrast 1, we compare the control group to no puppies to both of the 2 puppy groups, and that becomes our 2 groups that we compare to each other. And then for the second contrast, we're going to ignore the control group and simply compare the 15 minutes to the 30 minutes to see whether the amount or time that people spend in puppy therapy actually has any kind of an effect on that. So here's a couple other examples we could use based on the levels. So in this case, we have 1 control group and we have 3 experimental groups. So in this case, we could make more than 2 contrasts because we have 4 different groups altogether. So we could have 3 different contrasts. In this one, and it's the same type of principle. We take all the experimental groups and put them into 1 group. So that's E1, E2, and E3. And then we compare that to the control group. That would be contrast 1. Contrast 2, we ignore the control group and now put groups E1 and E2 together and compare that to E3. And then finally, for the third contrast, we ignore group E3 and simply compare E1 to E2. And that's the basic way that we go about, for the most part, setting up these kinds of contrasts. We compare all experimental groups to the control group, and then we break those experimental groups down into smaller and smaller chunks. There's another group as well where you have 2 different types of control groups. And in this case, for the third contrast, they're looking at the differences, potential differences within the control group as well. Okay, so before we move to post hoc tests, let's go ahead and look at the puppy therapy data and kind of go through how to do these types of planned contrasts. So we go to ANOVA, click on ANOVA. Then just like before, dose or dosage is our fixed factor. Fixed factors are your independent variables. And then dependent variables obviously would be the amount of happiness. So this gives us the same outcome as we had before, our f-test and our p-value. So now we want to go to the contrasts. So click here on contrast, and this is actually fairly simple to do. We're going to assume equal variances. We're also going to put in the confidence intervals for our contrasts. And then in this case, we want to just do what's known as the Helmholtz type of contrast. So we click on that, and notice what it does for us. In this case, here's the comparisons that happen. This type of contrast, the Helmholtz or Helmholtz contrast, compares the control to both 15 and 30 minutes. There we go. When we look at the T, we notice that is significant. Okay, so there is a significant difference between the control and the 2 experimental groups. And then the second type of contrast compared 15 minutes to 30 minutes. And that one is close to being significant, but not totally there. Notice how my p-value is slightly lower. So that allows me to look at and know these differences. Now, for the most part, we're going to be sticking with the Helmholtz because it does a pretty good job of laying this out. There's several other types of contrasts you can do. We never use the polynomial. If you want to look through some of these, like the deviation one does something slightly different. I mean, it takes 15 minutes in the control group and compares it to 15 and 30 minutes. That wasn't what we were really looking at. That wasn't really our hypothesis before. The difference one is a little bit closer, compares 15 minutes to control. So what you can do is, if you're not getting the contrast that you want, you can change the type of contrast that you're doing in order to get the one that you want. For our purposes, we're going to stick with the Helmholtz one. Now, there's a couple other things that we want. One is we want to go to additional options. And first off, we want to have those estimates of effect size. So we had that before. We also want to include our descriptive statistics. These are always important because this gives us the mean. Okay? And so notice that it gives us the mean of the 30 minutes of puppy therapy had a larger happiness score in comparison to 50 minutes in control. Then when we look at the Helmholtz contrast, we can also see that there is a difference between the two groups of control in comparison to 15 minutes plus 30 minutes. But that 15 minutes in control in comparison to 30 minutes, there is not a significant difference there. The other thing that we want to include here is we want to include our plot. Now, a plot is very similar to the bar graphs that we looked at with SPSS, but it does a few different sorts of things. So we take dose and we put that into our horizontal axis. Okay. Then, of course, we always want our display bars. We want to use the confidence interval. At this point, sometimes that can be changed. But what that does is when you look at the plot, notice how there's a pretty obvious difference between the control and the 30 minutes portion. And then when you add these together, we know that these are significant. So you can kind of see a general trend towards more happiness occurring because of more puppy therapy. And so these are the things that you're going to want to actually include when you're looking at these particular types of contrasts. So now I want to just kind of go over how we actually will write out these results. So let's go ahead and just look to how we do these. And it's fairly straightforward. We're basically just going to write down the t-scores and the p-values. Now, since there isn't any effect sizes included, I'm not going to have you add those at this time. We may find another way to do that later on. But for now, we'll simply write planned contrast reveal that having any dose of puppy therapy, so that means whether you have the 15 minutes or the 30 minutes, it significantly increased happiness compared to having a control, and that's where we write the T, our degrees of freedom, 2.47, and then our p-value. We can look that those are here, right here. Here's our degrees of freedom. There's our t-score, and then our p-value, so we've got those. But having 30 minutes did not significantly increase happiness compared to having 15 minutes. So then we have the t-score again, degrees of freedom, but notice that our p-value is above 0.05. Thus, there is not a significant difference between the two groups. Okay, so that's how we're going to write out these particular types of tests. Now, when we go to Now, the second type of post hoc tests, the second type of tests we can look at are called post hoc tests. And post hoc tests are different from planned contrast because you do not need to have a particular hypothesis. Instead, what the post hoc tests do is they don't really worry about particular hypothesis. They just kind of compare everything to each other, meaning that they simply kind of go through and take each of the means and they compare each group to each other. Now, in general terms, these tend to use a stricter criterion to accept an effect as a significant because you're comparing so many different means to each other and there's so many different tests co-occurring. You're actually going to increase or be a little bit more stringent about when you would reject the null hypothesis. And so hence you control what's called the family-wise error rate. The family-wise error rate. So post hoc tests, because there's often more hypotheses occurring at the same time, because you're comparing each group to each other, you control for what's called the family-wise error rate, the amount of different or the increase in number of null hypotheses that you're testing at the same time. So the way that we correct for this particular error rate is we're going to use what's called the Bonferroni method. The Bonferroni method. And this is the method by which we can try to control for or account for a larger range of a particular hypothesis. There's a lot of different types of post hoc tests that you can use. A lot of them do very similar things. If you go through and actually look at some of the different tests, the outputs you get are fairly similar. But they do most of the same sorts of things. So let's go ahead and go back to what we were doing. Let's go ahead and we're not going to have a contrast at this point. Instead, we're going to use a post hoc test. Go to a post hoc test. Now, it's a fairly easy way to do this. We take the dose, we bring it over. We're going to go ahead and have our confidence intervals, just like we've had before. We're going to have an effect size as well, which in this case is Cohen's d. That's a nice extra step to have. And then remember, we're not going to do the 2K, we're going to do the Bonferroni. The Bonferroni. And so the Bonferroni allows us to notice how we compare each group to each other. So we compare the control group to the 15 minutes, the control group to the 30 minutes, and then we compare the 15 to the 30 minutes. Notice how the basic output is still about the same, with some slight differences. So when you compare the control to the 15 minutes, notice how because of the Bonferroni correction, notice how it's no longer significant. Okay, we're at 0.845. So the difference between this group is not really where the significance lies. Also, when you look at 15 to 30 minutes, we've already known from before, our planned contrast also revealed that that wasn't the same. And we see that once again, that p-value is still above 0.05. The only difference that we have based on post hoc tests is between the control group and 30 minutes. That is actually significant, but it's also, once again, it's still just a t-value, just as we've seen before. So in this case, and if we look at the descriptives plots as well here, we'll see that we can notice that the 30 minutes is probably has the biggest difference between the control group. That's where the biggest difference in means lies, and that's what we see in the post hoc tests as well. Really quick, this is the way that you write out the results section for the post hoc tests. It's very similar to what we do with the planned contrasts. A couple things to notice here. You only have to write down the p-values. That's all you need to actually do for each one. And you do need to use this subscript key right here in order to, so like right now here I'm on subscript, to notice, to indicate that this is a Bonferroni corrected p-value. Okay, so the way we do this, Bonferroni post hoc test revealed that 30 minutes of puppy therapy resulted in significantly higher levels of happiness in comparison to controls. And you'll remember from our output, that's what we saw. Here's the post hoc tests. And you can see that between control and 30 minutes, the p-value is 0.025, which of course is below 0.05, so it's significant. But then that the other two were not, and so we write that down here. There was not a significant difference between 15 minutes of puppy therapy and control. Write the p-value, and then not between 30 minutes of puppy therapy and 15 minutes. Okay, so just have to list the p-values there, and that's all you need to do. So that's it for ANOVA Part 2. I'll let you know a little bit more about the homework here soon, and talk to you soon.